This lecture is Section 8, the mean and average, and the material is from Section 8 in Making Sense of Statistics, a Conceptual Overview. When we talk about the mean, a lot of times we will discuss that it is the most frequently used average. It is also so widely used that people refer to the mean as the average. One thing that I like to say is that if you consider the mean as the average and it's widely used, think about facial tissue. Now, most of you might go, I have no idea what facial tissue is. However, if I said Kleenex, many of you would go, oh, I know what that is. So when we are talking about the mean, we are probably thinking of it in that term as a facial tissue, but then when we talk about an average, we're looking at it as Kleenex. So let's talk about these symbols of the mean. So some of the symbols of the mean, the first one is called the X bar. Usually you will see this in mathematical statistics. And the next two symbols would be a capital M or uppercase M italicized and a lowercase m italicized. So the uppercase M italicized is used for the mean of a population, and the lowercase m italicized is used for the mean of a sample drawn from the population. Now, when we also talk about average, let's also say that the term average is very ambiguous because there are numerous types of averages that are used in statistics. However, in this particular chapter, we will only be looking at the mean. Now, one important concept to understand about the mean is that the mean is the balance point in a distribution of scores. So it is the balance point in a distribution of scores. Specifically, it is the point around which all the deviations sum to 0. And the mean is sensitive to extreme scores. Now, how to compute the mean? Well, computing the mean is easy. You probably did learn how to do this in 4th, 5th, or 6th grade. But since you're in college now and it's been a while, let's think about how we actually are talking about calculating or computing the mean. So the mean equals the average, and we add up all scores, and we divide the sum by the number of scores. So let's look at this example. So we have scores. We have 5, 6, 7, 10, 12, 15. Well, if we add all of those scores together, 5 plus 6 plus 7 plus 10 plus 12 plus 15, we have a sum of 55. Now, we then have how many scores? So we have 6 scores. So what we then do is we take 55, which is our sum, and we divide 55 by the number of scores, which is 6. This gives us a 9.166, and we can round the answer to 2 decimal places. So if you see this, that the answer was actually 3 decimal places and we have rounded it to 2, that is acceptable in research reports. The mean is usually reported to 2 decimal places. Well, now let's talk about what we mean by deviation from the mean. What we do is we then subtract the mean from each score to find the deviation from the mean. Now remember, we said the mean is the balance point in a distribution of scores. Specifically, it is the point around which all the deviations sum to 0. So let's look at the example below. So we have scores. Our scores are 7, 11, 11, 14, and 17. Now, if we add all of our scores together, we have 60. If we then count how many scores we have 5. Okay, so we have 5. Now, if we compute the mean, we have 60 divided by 5 gives us 12. Well, if we compute deviations from the mean, here in this table, you see that the scores are listed in the column under score. We have a mean, and then what we do is we subtract the mean from each one of the scores. So if we subtract 12 from 7, we have a deviation of -5 or -5. If we subtract 12 from 11, we have a deviation of a -1. If we subtract 12 from 11, again, we have a -1. If we subtract 12 from 14, well, we have a +2. And if we subtract 12 from 17, we have a +5. Now, if we are looking at this, we can add, and sometimes we talk about it as difficult for us to do that. But what we can do is we can simply count these out. So once we have completed all of the calculations, we have a sum of the deviations is 0. Remember that the negatives cancel out the positives when summing, which then yields 0. Now, if we substitute any other number for the mean and perform the calculations, we will not get a sum of 0. So only the mean will produce this sum. So the saying the mean equals 12.00 is a shorthand way of saying the value around which the deviations sum to 0 is 12. Now, a major drawback of the mean, one of the largest drawbacks, is that it is pulled in the direction of extreme scores. So extremely high scores will pull the mean higher, and extremely low scores will pull the mean lower. It will pull it down. Now let's look at the following example. So the following is an example of contributions given to charity expressed in cents by two groups of children. Now, so each number is a child. Now, if we look at the overall distribution, are quite similar. But now if we look at the mean for group B, we see that it is much higher than the mean for group A, because two students in group B gave extremely high contributions of 150 cents and 200 cents. So if only the means for the two groups were reported without reporting of the individual contributions, the mean for group B would suggest that the average student in that group gave about 21 cents, when in fact none of the students made a contribution of 21 cents. So a distribution that has some extreme scores at one end but not the other is called a skewed distribution, and you can go back and review section 7 to review the meaning of a skewed distribution. So here we have where you see that we had 1.24. Now here again, the extreme scores. A distribution that has some extreme scores at one end but not the other is called a skewed distribution. Now, the limitations of the mean is that the mean is almost always inappropriate for describing the average of a highly skewed distribution. And the average that provides a more accurate indication of the score of the typical participant in a skewed distribution is discussed in another section of this book, actually in section 9. Another limitation of the mean, that it is only appropriate for interval or ratio scales of measurement. Now, if you do not recall those, you need to back up to section 4 to review these scales of measurement. So averages that are appropriate for use with data at the nominal and ordinal levels are described also in section 9. Note that a synonym for average is a measure of central tendency, and although the term measure of central tendency is seldom used in research reports and academic journals, you may encounter the term in some statistical text. So remember that it is a synonym of average. The term measure of central tendency is a synonym of average. This concludes section 8, the mean and average in making sense of statistics.